Hello everyone, thank you for attending. Today I'll be talking about the challenges that come with large-scale Angular projects and why the default structure isn't simply enough for productive development and maintenance of such application solutions. I'll start by overviewing a typical Angular project structure that usually has a root module that's initialized as soon as the application is started, and all of the shared services are usually separated into a core module that can be shared across different feature modules. Every specific business logic and set of features is also separated as a feature module that can be loaded only when used, and all of the shared components, directives, etc. are usually separated into a shared module, which is shared across feature modules. So with this standard enterprise app structure, I'll even give an example. I'll demonstrate the application generated by Hipster. That's why the logo was there. And after that, we'll see how to go from there with a mono repo approach when you split into multiple projects, when you split your code across different repositories and packages as your dependencies. And finally, I'll demonstrate how to integrate large-scale Angular applications in the new concept that's called microservices on the front end, the micro frontends. These are some pointers to get started on this journey towards large-scale applications. The first one is the book, Large-Scale Web Applications. The second is the ng-conf, where they propose new approaches to these problems. We are developers, and the local community here in Novi Sad, NSJS, where multiple solutions multiple approaches to micro frontends were discussed. And this man here. This man is Manfred. He's an Angular consultant working as an active part of the Google engineering team. And he consults companies that have to deal with extremely large enterprise Angular applications. So much of these practices are some of the ones he proposes to companies. How I got into large-scale Angular applications. At first, we had a single application that was meant for our end users. And the applications had some graphs and features, etc. But with time, we extended the app, actually cloned the app, for a subset of our end users. This was the more advanced app that actually provided some analytics and dashboards and lots of different features. But the main thing is that the app 2 was made by cloning the app 1. Since all of the diagrams, charts, and features were essentially used in app1 and extended with new ones. And sometimes we also had to implement new components in the application 2 and then port them back into application 1. And as soon as we got over 10 or 20 modules, it became frustratingly difficult to maintain across different projects. So the main idea was, with the standard structure, is that feature modules are not even loaded in the browser until used, which I mentioned. And you can see here that the sample enterprise application here is divided into bundles, which are actually the final distributed JavaScript code. The feature 1 module is in the feature 1 bundle, the feature 2 is in feature 2, and only when feature 2 is accessed, the actual JavaScript file is loaded. This is the minimum, this is the first step towards larger Angular applications. When you start to code split a large Angular application, such as this one, the first thing you'll have to do is get rid of requirement paths. What I mean is the standard way to import a module in Angular is ... relative paths from the current module. And if you delete a folder from that structure, or move it, you'll have to rewrite all of the import paths. The solution and the pre-requirement for further steps is to get rid of relative paths in your Angular application and replace them with path aliases. They, in a sense, make symbolic links towards some of your modules. For example, this is the most simple way of setting the path aliases up. You simply use the TS TypeScript compiler config, and you put in your paths, your aliases, and the physical folders the TypeScript compiler should look in when you import something from add feature or add common. And then all of your imports will be refactored into something like in the code below. Import shared service from common. No more dots, no more relative paths. And actually there are tools that can automatically scan your code base, command line interface tools, and automatically refactor all of the relative paths into aliases. Examples of this approach, I've created, I think, 5 or 6 code demos that I'll show today. The first one is the Hipster, and it is the simpler of these two. Let me just... if you ever use Hipster, it's a domain-specific language generator that can generate a whole Angular app based on your specification. And its structure goes something like this. The root app module shared, and some specific modules with entities, CRUD applications, etc. Its TypeScript config uses a trick. It uses app. This is not exactly a symbolic link, but actually it enables you to write, instead of relative, absolute requirement in import links. So when you import something in your code, you actually write the absolute path starting from the root of the project. So for example, okay, all imports are essentially as app, start from the app, which is the first step for further refactoring. And this app, specifically, there is an online demo that uses just user. This is all generated using the outdated generator, but this was the one that I found working online. Lazy splitted modules across different sections of the applications, and that's pretty much it. The more advanced version is the Fuse Angular 7 team, which was done by a very smart man. It's a commercial team that its license costs around 900 euros, but it's, in my opinion, it's totally worth it. As you see, this is like a showcase for this team. All of these features are actually sub-applications in this project, and they're implemented using just feature modules, but elegantly structured and separated. So its code structure looks something like this. Source, a common utility module as a aliased library, and there's an app path with all of the mini apps in it. Just a sec. main apps. Okay, so all these modules are lazy loaded. Actually, the entire app, even including the main module, is lazy loaded. To achieve this, all of the routes had to be well thought out before starting any of the modules. So anything on the path/academy is a module for itself and loads only when you access /academy. And all the services, etc., have been implemented as sub-modules of this feature module. And this can indeed go for extremely large length and projects, but it also imposes some limits if you have to deploy them separately, since this is a single project but with a well thought out structure. In order to go beyond this, the newest edition of Angular replaced the Angular CLI with the Angular JSON. It's no longer used as a list of commands. It's actually used as a manifest for a whole project. Angular projects are now treated as workspaces that contain many projects and many libraries that are built into the project. To demonstrate this new approach, I've generated a sample app using the engine new generate, and the new arguments are the type of application you want to generate. You can now generate either just applications which have source, app, module, etc., or you can generate libraries now. Generating a library creates a package JSON and a index TypeScript file, which is the public API of your library. And for example, if you execute those commands, you would get something like this. This is the demo app created using the commands. And notice the difference in structure. There is a source folder, which is the main entry point of the application. But now there's a projects folder with each application as a separate folder, which has a complete Angular project structure with its own source, package JSON, and test lint. And the library project also with the source with its public API TS, which exports all of your module services that you want to share across different applications or projects. And the Angular JSON integrates the path aliasing as a default way to include everything in your project. So test config. All of the paths and search paths are defined, and each submodule references itself with @feature1 @module name. And essentially, you could even leave out the source folder in the root by specifying create application false. That way, you'll create something that's called a monorepo, which serves as a Git repository for multiple Angular applications, and there is no entry application, and you can keep all of your libraries and projects in a single place. As soon as you start doing multiple applications and multiple libraries within the same repository, one of the difficulties you'll encounter is during code splitting, you might receive some cyclic dependencies, and you might start to wonder why are some parts of the other applications intertwined with the first one, and you'll need sometimes to optimize the end build product JSON file. This tool, NXDev, is a tool that optimizes the Angular CLI, supercharges it with tools that can help you build more efficiently and code split more efficiently, since it detects all of the dependencies between multiple projects and multiple applications and libraries, and you can even use its own command to perform some of the code splitting. It also enables you to more easily package existing applications into small libraries that you can publish later on. So when you have all of your code, all of your projects and libraries in a single repository, you could even place multiple projects into a single repository. This is what Google does. Google uses a organization-wide single repository. And for example, Gmail and Google Analytics are just projects within the same repository. And when someone wants to start a new project within the Google repo, it's forced to use the same version as any other Google product. Same dependencies, same projects, same libraries. This enables extensive code sharing and reuse. All of the applications use the same versions of all the libraries. There's no code conflicts. If you say that if your main target is the latest Angular, all applications within the large organization-wide repository will use the latest Angular. This comes with a lot of benefits. The benefits are the largest benefit is the lack of version conflicts, but collaboration across teams gets more difficult. Since code ownership is diminished in this case, since everyone has access to essentially everything, and sometimes there are some there are some protocols or procedures that you have to go through to gain access to a single project, instead of just having your own project and sharing it with others within the organization. The alternative to a monorepo is to just put everything in a different place, physically different place. Every submodule code library would be published somewhere else. This could be a GitLab repository, since you can use in your package JSON, you can specify the standard npm repository, but you don't have to. You can use the Git plus HTTPS link, and you can simply link to a Git repo, and when you perform npm install, it will download the code from the master branch if you haven't specified otherwise. There's the option of using a shared file storage, file server, and using the file protocol. This means that when you perform npm install, your machine will try to copy the files from a shared file server. And the most used is the private npm.org repository, where your code isn't public on the npm, and you have to log into npm to perform an npm install. There's actually a command npm login that prompts you for your credentials. And the final one used in large organizations is the personal npm registries. This is an approach used mostly by companies that rely on Team Foundation Server, that use C# and .NET technologies. Team Foundation Server can store all of your packages and act as a npm registry. But in order for npm to use a custom registry, you have to make this file .npmrc that has to be in the root of your project. And in there, you specify the location of your special your custom npm registry, which is often somewhere in your local network. Yeah. And this is the final stage of your application. Since you've code splitted your code across multiple repositories or a single multi-repo, monorepo with multiple projects, sometimes the application itself gets too large, and sometimes it's difficult to determine which version of Angular should be used across all projects. And some teams might want to try out a different technology for a specific feature. For example, we had like 7 Angular applications on our end, and there was one specific feature that could be done really easily in React. But we were stuck with the monorepo, and we had to place that project totally outside of the current repository. But if we switch to micro frontend, things could be different. What are micro frontends? This is the manifest and the actual foundation promoting the term micro frontends. Essentially, as we're code splitting our APIs and backends into multiple applications that can be maintained and created and developed by separate teams, usually 2 pizza teams, that form contracts with other teams working on APIs. The similar scenario is happening in front-end development, where, for example, the Amazon.com is actually split into multiple different front-end applications. So when you visit the Amazon.com, the shopping cart is an application for itself. The suggested products is an application for itself. And the main product screen is actually an application for itself. Some are done in Angular, some done in React. To do this, we usually have a shell application, the one that listens for browser navigation, and the one that holds everything together and shares information and events across multiple micro applications. An elegant way to use micro applications, micro frontends, is to use a special library as a glue that bootstraps different applications when you navigate to different parts of the page or when they are required. One library that's been battle tested and used across different projects is the single SPA.js, which actually relies on web components that enable you to use custom elements in your browser. Some adjustment to Angular and React application is required in order for this to work. You have to integrate your code with the single SPA. So when the user navigates or the application is required to be used, your main entry point for your Angular application has to be triggered outside of Angular. So you do this by implementing a call to the single SPA Angular, and you register your main module, and you give a unique template name for your application. So when it's integrated in the browser, it has a unique tag name, which is registered as a custom element in the DOM using web components. Okay, and the tricky part is sharing state between these applications. So because as you navigate through the applications, the DOM and the page is usually destroyed and re-rendered. In order to maintain your JavaScript objects across different modules and applications and languages, you'll have to create some kind of a global event bus and a global store for storing global data and your single application data. This can be done using any sort of event bus. The one I have here as a demo is using just the window object and using the content messaging inside the browser itself as a event bus. And I'll show you a sample of single SPA demo. This one is a simple, this one is without a shared state. This is a micro front-end oriented app with the first application being in Angular, I think, yeah, in React, and the other in Angular. So there's always the shell application that has to bootstrap everything. That's the root application, and it's loaded as soon as the application is loaded. Its job is to register paths related to different applications and when they should be integrated and rendered in the DOM. For example, the application 1 here is only invoked when you navigate to app 1. The difference is when you navigate in app 2. And the Angular application was integrated using the app2.js file, where we had to import our entry point and our main module of our application. And we had to implement the standard life cycles that every single SPA application that has to be integrated into a larger one needs to offer. Each single-page application usually needs to bootstrap its services, modules. It has to be rendered and placed in the DOM, and when it's not used, it has to be removed from the DOM, and this is the unmount call that does exactly that. For the React app, the same integration as well. Bootstrap, mount, and unmount. Register all of your context, all your services, mount and render your application, and unmount your application. And the one with the shared store and event bus is this one. It actually has five applications. One is written in React, Angular 7, Angular JS, Vue, and another one in Angular 5. Its shell application, the one that glues and holds everything together, is a bit more complex this time, but it's mostly just pure JS that relies on the window object. It offers a register and dispatch methods. You can register to an event and dispatch events. Everyone registered to an event will receive it, and files and objects stored will be persisted in memory. And the applications themselves, even though they are a bit more complex now, are still just normal applications that have to implement the entry point for the single SPA that just offers the bootstrap, mount, and then unmount entry points.